Just want to give a little review here of factors, factor trees, and what that means for prime and composite numbers. So I just want to remind you that factors are the numbers you multiply together to get another number. So when you look at 2 times 3 equals 6, the factors are 2 and 3, the numbers that you multiply together to get 6. If there are only 2 factors, the number 1 and the number itself, then the number is prime. For example, the only thing you can multiply together to get 2 is 2 times 1, itself and 1. 3, itself and 1. 5 times 1. 7 times 1. All those numbers are prime. If the only other factor is itself and 1, then the number is prime. So that's the first step of looking at the factors. If there are more than 2 factors, then the number is composite. For example, back to 6, 1 times 6 equals 6, and 2 times 3 equals 6. So it has 4 factors. It is not prime, it is composite. 12 is composite. It has 6 factors. 1 times 12, 2 times 6, and 3 times 4. Now, I've shared with you before that the way I like to find factors is starting with the number 1, because 1 is always a factor. So I kind of pair them up. 1 times what will give me 24? Well, it's 1 times 24. So those are 2 factors. Then I just start numerically down. Will 2 times something equal 24? Yes, it will. 2 times 12. Will 3 times something equal 24? Yes, it will. 3 times 8. So I'm just thinking numerically of what could possibly be factors. How about 4? 4 times something? Yes. 4 times 6. How about 5? No, doesn't go into it evenly. How about 6? Well, yes, we know 6 does. We've already used it. So once I get to a number that I've already got in my factors, then I know that I have all my factors. That's why I like to go sequentially like that when I'm looking for my factors. So 24 is also composite. There are much more composite numbers than prime numbers. So we use this in a couple of different ways. One way is in a factoring tree. So when we complete a factoring tree, we're trying to get down to the most basic prime numbers of what it takes to create that number. So if we start with 36 and choose any 2 numbers except for 1 and 36, we want to choose something other than 1. So if I start with 3 times 12, that makes 36, and I'm looking to try to get all prime numbers. Well, 3 is prime, but 12 is not. So I'm going to bring my 3 straight down. It's prime. I don't have to do anything else to it. What times what will give me 12? Well, 3 times 4 will give me 12. So is that all prime numbers yet? No, it's not, because 4 is not prime. So I'll bring down my 3. I'll bring down my 3 because they're prime. And then I'm going to branch out here for my 4, and 2 times 2 equals 4. Now, when I look at those numbers, 3, 3, 2, 2, those are all prime. So I know I'm at the very bottom of my tree, the base of my tree. And if I said 3 times 3, that would be 9. 9 times 2 is 18, and 18 times 2 is 36. I'm just double checking to make sure I didn't make a mistake. I can put these in the form of exponents here to get it in its most basic form. So we could do the same thing here, choosing 2 different numbers. Instead of 3 and 12, let's choose 4 and 9. 4, 2 times 2 equals 4, and 3 times 3 equals 9. Well, looky there. With that choice, I got straight to my prime numbers on the first shot. Sometimes you do, sometimes it takes a little bit longer. And I could show that in exponents. Oh, that's a 2. That way. Now, another use of factors is finding the greatest common factor to simplify a fraction. When I see the fraction 9/12, I know that it's not in its simplest form. There is a common number that divides into them both. If you find the greatest common factor, that tells you what it is. So here are the factors of 9. Here are the factors of 12. What is the greatest common factor? Now, the lowest common factor is always 1. That won't work. We're looking for the greatest common factor. That is 3. So if I divide both by 3, then I should simplify my fraction. 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4 is in its simplified form. So I want to look at 16 and 24. Let's simplify it, finding the factors. The factors of 16 are 1, and I like to buddy them up. 16, 2 times 8. Does 3 go into 16? No. Does 4? And 4 goes into it 4 times 4, but you only have to list it once. And then does 5? No. 6? No. 7? No. 8? It's already there, so I know I have all the factors of 16. Let's look at the factors of 24. I'm always going to start with 1 and its partner, 24. And then I'm going to think in my brain, does 2? Yes. 2 times 12. Does 3? Yes. 3 times 8. And does 4 go into it? Yes. 4 times 6. Does 5? No. Does 6? Yes, it does. And so I'm back to where I have. Now, what is the greatest number on both sides? Well, it looks like 8 is the greatest common factor. So if I divide by 8, I'm going to get 2/3. So that is using the greatest common factor to help simplify a fraction. Those are the two main ways that we use them, and I just wanted to review that with you.